Hey guys, welcome back. Another exciting day for math. It's Friday today. We've made it through our first week of online learning. Today, it's just business as usual, right? I've got my Pride Land dress on. I'm ready to do some more math. So let's go ahead and jump right into it. Today is lesson 26. Our learning target is I can decompose whole number fractions greater than 1 using whole number equivalents with different models. That's a mouthful. Let's break that one apart just a little bit. So first it says I can decompose. Decompose means to split something up or break it into pieces. So I can split into pieces whole number fractions. We were learning about whole number fractions recently. That's any number that's a whole number written as a fraction. Now we're looking at whole number fractions that are greater than 1 whole, and we want to split them apart using different equivalence models. So we might use 2 halves, or we might use 3/3. Those are all fractions that are equivalent to 1 whole, and we're going to use those today instead of using individual fractional units. Let's look at this application problem. Now remember, if you want to challenge yourself today, pause the video after we read the application problem together and give this problem a try. I'm going to jump right into the explanation after I finish reading it. So if you want to give it a shot, pause it right after. It says, Antonio works on his project for 4/3 hours. His mom tells him that he must spend another 2/3 of an hour on it. Draw a number bond and a number line with copies of thirds to show how long Antonio needs to work all together. Write the amount of time Antonio needs to work all together as a whole number. So, first, let's start with our number bond on this. We know that Antonio already spent 4/3, and I'm going to write it in fraction form, 4/3, it says right here, of an hour on his project. His mom says he needs to spend another 2/3 of an hour on it. And here's the number bond right here. Here's the different parts. We need to figure out what goes in here. How much altogether did he work on this? Since he's doing it more, it's just going to be, we can also add a little plus sign here if that helps us remember that we're adding these together. So what do? Let's go ahead and make a number line. I'm going to draw a number line here. And I'm going to make sure that I have enough space. So we'll start at 0. Let's have this number line end at 3. So I'm missing the numbers 1 and 2 on here. So now I've got all my whole numbers on here. And it tells me to draw a number line with copies of thirds. So I'm going to split this number line up to show thirds. So every time I have 1 whole, I'm going to split each whole into 3 pieces. Here's another whole, split it into 3 pieces. Here's another whole, split it into 3 pieces. Now I didn't split them perfectly, but that's okay. It's going to be good enough for what we're working on here. Let's find out how much time he's already spent on the project. So now our number line is in thirds, so each increment is 1/3, or each time we run into a mark, that's 1/3. So let's count it out. 1, 2, 3, 4. Here's 4/3. That's how much he spent here. And then his mom says he needs to spend 2 more thirds. So here's 1, 2 more thirds, and we were at 4/3, so 5/3, 6/3. We're now at 6/3 on the number line, which also happens to be where 2 whole is. So when we're writing our answer, we would say Antonio worked on his project for 2 hours. And that's going to be our answer. I didn't write it out completely. I wanted to save you guys a little bit of time so you don't have to just watch me writing that out. Let's look at this number bond. Now, as we've talked about number bonds, I've mentioned that it's important that the inside of the number bond is always equal to whatever is outside of the number bond. So let's check to see if that's true for this number bond so that we know this is a good and great number bond. So we're going to make our line. We want to make sure that we have enough space. I'm going to put this one from 0 to 2. I need 1 to be added in here. It says halves, so let's start with that one. We're going to split each whole into a half. So here's one whole, we split it in half. Here's another whole, split that in half. Let me mark that this is one whole. So I have 1/2 and another half. This is where I'm talking about on the number line. This is my spot. I'll draw a little arrow. And this is 2 halves. I'm going to use the same number line. I'll use a different color. But let's see, I have got 4/4. So I need to split each whole into fourths. So I'm going to split it in half first, and then I'm going to split each half in half, and that'll give me fourths. And I've got 1, 2, 3, 4. 1, 2, 3, 4. Look at that, we ended at the same spot. And since we ended at the same spot, we know they are equivalent. So this number bond is good. What happens though if I add to the middle of this number bond? I'm going to add another 2 halves. Now this number bond can't be true because there's now more on the inside than on the outside. They're not equal. How many fourths am I going to need to add to balance this back out? Well, for every 2 halves I had, I needed 4/4. Since I added 2 halves, I'm going to need to add 4 more fourths. So 1, 2, 3, 4. And we're showing whole numbers. We're decomposing whole numbers using different fractional units, just like we were supposed to from our learning target. But this is getting pretty big. What if I start getting to the number 5 and 6? I'm not going to have enough space for all these fourths. That's where this comes in. This block is showing us one whole written as a fraction, 4/4. We know that one whole is equal to 4/4. We found it right here. One whole is also 4/4 and also 2 halves. So let's look at some number bonds. This is the number bond that we created just now, and this is another number bond where instead of using 1/4, we're using 4/4 for each of our pieces. And we want to check on this number line if that does work. So since we're using fourths, well, let's first make sure we know where the halves are. So we're going to split this number line. Each whole gets split into half. Here's another whole. I'm going to split that in half. And I'm at 1, 2, 3, 4 halves. 1, 2, 3, 4 halves. I'm going to put a little circle here so I know this is where I'm trying to get to. Let's look at this model first. So I'm going to split this up into fourths. It's already split in halves, so I just need to split this up. Each half gets split in half. Each half split in half. And let's go ahead and count them. We have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. This spot on the number line, 2 whole, is equal to 4/4. And we broke apart this whole number into fractions. Let's look at this model now. We'll do this one in blue. Now this is saying I'm going to count 4/4 all at once. And so it's going to be a bigger jump. Let's see if we end up at the same spot. 4/4 and another 4/4. 1, 2, 3, 4. So I'm going to make a big jump. 4/4. And then another 4/4. And I'm going to end up over here. And it's still 8/4. So here's 2 different ways that we can show how to break apart a whole number from a fraction into a different set of fractions. Let's look at the problem set. Question 1. It says partition, remember that means to break apart, the number line to show the fractional units. Then draw number bonds using copies of one whole for the circled whole numbers. So as we're going across this number line, we're going to say, oh, well, what is this as a number bond, this whole number as a number bond. Right here, partition the number line to show the fractional units. It's asking us to show halves. So we're going to look at each whole. 0 to 1 is one whole. We're going to partition that into half. Here's another whole. We're going to partition that one again into halves. When I am at the starting point, I don't have any yet, so I'm at 0 halves. And if I don't have anything, I can't make a number bond for it. There's nothing there. Then I'm going to get over here. How many halves does it take to get to 1? 1, 2, 2 halves. I'm going to mark that in. 2 halves. Here it is as a fraction. 2 halves. Now, since it asked me to draw a number bond using copies of one whole for the circled whole number, the whole number is 1 here, and they want a number bond using copies of one whole, well, this number bond is not going to be very exciting. It took 2 halves to make one whole, and there's only one other piece. But the inside of my number bond is equal to the outside. Let's look at this one. We know that we're at 2 halves right here, 3 halves, 4 halves to get here. And they already told us 4 halves in fraction form, so we're just filling in this blank. I have 2 halves in this part of the number bond, so let's add another 2 halves here. Let's say this number line continued, that we looked at it past that point, and we went to 3. I'm just going to draw it over here. Following this pattern that we have, I know that it's going to take 2 halves for each whole, and I have 3 wholes. So 1, 2, 3. And I can put these in a little circle. I like to do the circles after I've written the numbers so I can make sure that the numbers fit and I can read them all. But all of these lines should be going to this main number, this whole number. So I can see, oh, look at that. I put the wrong number right here. 2 halves. I've got 2 halves, 2 halves, 2 halves equal to 3. Go ahead and try out the problem set. If you have any struggles with it, let me know. I look forward to seeing you guys next week, and I hope you enjoy your weekend. If you've got any fun weekend plans, please let me know, and I'll see you Monday.